So I believe you can all see my screen. Hello, can you see my screen?
Yes, sir.
All right. So today we'll be going into the third section. Yeah, we've done section 2 last week, and last week we talked about the differences between the artificial intelligence, machine learning, and deep learning, and the types of or classifications of machine learning that we have. So in this section, we'll be going into data collection, data processing, and exploratory data analysis. So I believe, yeah, in level 2 of our internship, we've done most of this data visualization. So we are just taking it a little bit further because now most of our data, most of the things we'll be doing is so that we'll be able to, I don't know how to put it, so that we'll be able to use them for our models. So that's why we are going into it. And if possible, if you have the time, we'll download the data set, a raw data set, and try to process it. So now the section 3 is on data collection, data processing, and exploratory data analysis. So the data collection, now what is data collection? So we can just describe data collection as another name we can give for it is data mining. When we say we are mining, that is, we are extracting information, we are extracting something. Just like people that are into maybe gold mining and all that. Maybe some people say they are mining coins, that is getting that thing. So when we are talking about data mining, it means collecting data, extracting data. So the objective of data mining is for us to what? To gather relevant data from various sources. We need just for us to be able to gather data. And those data are gotten from what? Various sources. So, and no model now, because we'll be hearing more of model since we are talking about machine learning. We are talking about artificial intelligence. So you hear more of model. So no model can perform very well on data that was not properly collected. So that is, our model can only perform well. The quality of the performance of our model is determined by our data, is determined by the quality of our data. So we need to ensure our data is properly collected. And by the time we collect data, we might not be able to collect the data might not be collected perfectly well. That is the reason why our data also needs to undergo what? Pre-processing. So for it to meet the standard and quality of data we are expected, that we are expecting. Yeah. So the choice of data source and data quality at this stage determines the ceiling of our model performance. That is, the choice of the data source you determine to use. Where are you getting your data from? Can you trust the source of your data? And the data quality you are getting from there will determine how your model will perform. So that is why emphasis is usually placed on data collection and data processing. And most of the works you will be doing when you are working in when you are doing machine learning, when you are creating a model and all that, most of the things you'll be doing, most of your codes will be majorly on the data part, visualization, data pre-processing and all of that. Yes, you actually write codes in your model and all that, but we first need to make sure your data is right. You've gotten your data right, and that is when you can now start writing the models, selecting models and everything. So, and what are the common data sources that we have? We have databases. Yeah, so SQL is a structured query language used for writing databases. We have MongoDB. So these are databases are structured records. They are records that are structured, and these are usually from organization systems. Maybe some companies, they can have their database, that is the record, maybe the record of their staffs. They will create it in a database. So we can get data from databases of organizations, some that might be publicly available. We can request for them. There are ways to access data from databases. So, and if you are working with databases, that is an example of the language ways to work with databases is through using SQL, MongoDB, and the rest. So data, we can also get data from CSV or Excel files. comma separated zip value also, CSV files and Excel files. So this one of the common ways, yeah, is the most common starting point. Most of you are downloading data online, the data set you'll be downloading most of the times are CSV. Yeah, CSV files. So this is common way we do get data for our data science projects. So databases now is used in maybe when you are working for an organization or a company or so, and you need to work with some data. After you build your model, you still want to test it on their data, or you still need to give it some more data. Maybe you are working with a bank or so. You will now need to work with databases in those kind of instances. So since those companies or the organizations, they have their records. So you can just start to work with their records, their database, and use it on your model. But when you are working on your data science project and all of that, you might not have access to the databases. So what you just have access to is what, like an Excel file, a CSV file. Yeah, and all this can also be gotten from the database, but should have been extracted and converted to this format. So this is the most common one. Another method of getting data or mining data is web scraping. There is a one of our video section that we did in another series called Tech Catalyst series. When you search our YouTube page and DBS Technology YouTube page, just go to Tech Catalyst series. I think whether video 3 or 4, so we talked about web scraping, how you can extract data from websites by just writing programs using Python. And some of the libraries you use is BeautifulSoup, Scrapy, and there are a lot more libraries, but these are the common ones. So you write code. You can just, when you are free after this video, you can just go out to check it out. You see how web scraping is being done. You write code, it will extract data from websites from you just based on what you want. Like the one we did in the video, we did that for, yeah, want to extract the weather information, news, to extract news from some website and to give us the headlines. So one is to check for jobs, job posting. Whenever there is job posting, it will extract the data and compile it into a single file for us. So you won't have to, it's just give you those information, even put the link, the description, the company, the role, whether is an entry role, professional role, so like that. So it will categorize it, to put it into a file for you. And we even did one on trading, maybe for those. So that is just like examples of how you use web scraping. So one of the ways you can get data is through web scraping. Yeah. So we have some, I think there was this person, a guy in Unilag that time, that created a data set that was on, most of the data there was gotten through web scraping. So there is just an ethical part to it. It's not all websites you can scrape. One, so you need to understand, if you are scraping a website, you need to know if they allow it. And also, since when you are doing web scraping, you are not the one really, you are writing a program. So it's just as if it's like a bot doing the work for you, gathering information. That's why in most of the sites you see, they will ask, are you a robot? Because if by the time you start having multiple people performing web scraping and like bots working on your site, it slows down the traffic. Like people that really need the data might not be able to access it, maybe due to some activities going on this website and all. So even in the video we did, we had a way that we had to reduce the number of times I extract data from that website, because if it's not done like that, the website, yeah, I think it was a personal project. It was not in that video. It was on a personal project where we were working on an e-commerce website. So we need to analyze, and on relating to web development, we need to analyze and compare some indexes and some things on some e-commerce websites. How easy it is for customer to access the site, how fast is it, how accessible, accessibility. So there's a standard for it. So are they following those standards? How is their maybe images meant to be put, like some information to be placed under it? So all that work, we have to now use create like a bot to scrape the web, just for those information goes to that website, check and give us results. Then it goes to the other website, almost, and it will get to the checkout page. Though we didn't just allow you to check out, because in checkout you might need some credentials and all, and don't want to, because of the security part of that. So we just stop at that point. But because of the way those sites, one of those sites was Amazon and all that, because of the way they are, they have a way they limit their information. If you just start running your codes on it too much, they have a way they will limit the connection and it will start bringing timeouts. It will not give us the expected result. So we have to limit the number of times we run our codes on that site and all that. That is just example of how web scraping can be used to get data. Another example is APIs. Twitter's weather service, financial data. Most of all the services we use today, most of them use APIs in the back end, where maybe you are getting weather services or so on another app. It's not the app or maybe the company that's actually providing you that service. They are using an API to get that service from another maybe company or website responsible for that. So that you can get data from what APIs. So another one now, this part, sensors and IoT, this is related to people into hardware. Now, if we even have it as the world is going, the impact of IoT has been existent since, but yeah, we will have it to still grow over time. And now that we have a term called edge computing and the rest, so where you have data residing inside edge devices like mobile devices, wristwatch, smartwatch, things we use. So now we have some sensors that might have been placed there to determine temperature, maybe temperature of my own body. Maybe a producer of a smartwatch can get all your data. By the time my own watch is determining my temperature or some informations, and that person's smartwatch determines that, they will send all those information to a particular network. That is the Internet of Things. So from that way, you can get data. Or you can create your own hardware device and just play. You want to get data about the weather of a particular area, humidity and all that, and just create a model that will make some decisions. So you can decide to just create some sensors and place them in strategic location to get those information, and they will send it to you through the internet, and you get your data from there. So those are examples of common data sources. Another one is surveys and forms. So these are another primary data, and another primary way of collecting data. Yeah, so this most times if someone wants to develop maybe a new app or that, or you need a particular information, you just create a survey form, you send it out to people, please help us fill these things. So this one is used to collect data directly from stakeholders, the people that is usually using that stuff, that can really give you information. Though sometimes people might decide not to respond. So I think that's just some common data sources, some common ways you can get data. So an example is, we want to predict whether a student will pass or fail a final exam. So we need to get data to predict that. So how do we get the data? So we can just decide to create a survey and just send it to the student in a particular area. So to get their record, so they will fill those informations. Or we can decide to maybe go through the school database, the school records, and get those informations from it. So now we will collect maybe 2,000 student records. It contain attendance, percentage, the assignment average, the hours they study. So we can create a survey for that. The student will tell us how like the time they attend class, how many class they missed, how many did they attend, assignment, what is the average score they are getting in the assignment, how many hours did they study, and the exam they did, what was the mock exam they did, so maybe like a test, and what was their final result. Did they pass or fail? By the time we collect that data, maybe for example, at least 2,000 students, we've created like a data set that we can use. So that is for data mining and data collection. So I don't know if if you are with me and you are getting it, and just let me get a response. Hello, I don't know if you are getting it, let me get a response. So I'll
Um,
know it.
Yes,
I get it.
getting it. I can hear.
All right. So now we move to data processing. So we call it preprocessing. So data processing involves cleaning and transforming raw data into usable formats for analysis. So this is basically the part we'll just try and work on. The part of data visualization, we'll just talk about it and we might not be able to do much. The part of visualization is this exploratory data analysis, because we already have like a video on it, and like most of you on this call too, you knew that already. So for those that might be watching the recording also, there is a video on our YouTube pages that talk about this also. So we'll just be focusing majorly on data processing. So it is one of the most time consuming steps, as you can see. I'm coming. It's one of the most time consuming steps in any data science project. This is where data scientists spend 60 to 80% of their time. Can you see? So most of the time you'll be working on your project is spent there, because if your data is not okay, it's not right, it's not having a good quality, you can't proceed to your model part. Because the golden rule is garbage in, garbage out. An algorithm, which is what we use to build our model, is an algorithm we use to build our model. So an algorithm cannot compensate. It cannot compensate for dirty, incomplete, or biased data. One of the reasons why we also need to process our data, your data might not be having maybe missing column, duplicate, or anything, but you still need to process your data. Like you can see this time here, because especially when you are creating a model, you need to take note of this word, biased data, to check. That is why we might naturally not need exploratory data analysis. We perform exploratory data analysis to visualize our data, to really see, is our data biased towards a particular set of people, towards a group of people, towards a particular location, towards this set of people. So to check for bias, we also need to process our data. So why do we need data processing? To ensure data quality. It removes error, inconsistencies, duplicates, and it's what? It enhances the accuracy of our model, because once our data quality is being improved, our models will have a higher accuracy. So cleaner data leads to what? Better predictions. And another reason is it handles data issues, missing values, wrong format, because when you need to make sure your data are in the correct format. Outliers, it can remove outliers, because outliers, sometimes if care is not taken, it will affect your results. So data processing will help you take care of outliers. It also facilitates better insights. And how can you get this insight? From EDA, exploratory data analysis. This is usually used mostly by data analysts. So, but you also need it while you are working in data science projects, because you first perform data analysis before now getting to your part of building a model. So, and it enables better decision making at every subsequent stage. So these are the reasons why we need data processing. So, and what are the components? We'll be talking about the technique, the problem that technique solve, and what is the method we do use. So you need to be familiar with this an example. So because that is how it gives you an hint on how you process your data. So first, when you get your data set, you need to explore and check your data, view it to know, check for some informations. Then you start checking, oh, if there's missing value, handling missing value, what are you going to, what does it mean? That is, you want to remove incomplete data feed, or what missing values means incomplete what? Data field. And what are you going to do? How do you handle that? If the missing data field is like numbers, it has some figures, so you can decide to get the mean. Once you add all the figures in that column together, and you get the mean of it, and you impute it into those missing data feed. Sometimes you get the median. Maybe if it's like a score, maybe you can just say, oh, this score, some are scoring, just get the median, the score that most people are getting. You just impute it there. So you can decide to use mean or median for data with figures, figures, data feed that has figures and the rest. So any one of it, you need to just check based on your data. You see, oh, I think it's mean that would be better here or median. So for numbers, you can see mean, median, imputation for what? Numbers. So, but while you have categories, let's say maybe categories of people that there categories, maybe category of people that survived or that did not survive. Like in case of the common Titanic data set, I think that was an assignment, a task for level 2. Most of you have not finished that. So you have the Titanic data set, for example. They said some people survived, some did not survive, and all that. So now you know that is categories. You've categorized people, or you put people into category also. So now let's say you now have missing values there. What do you do in that case? You will replace it with what? Mode. Which category is occurring the most? You will replace it with it. So you drop row if the missing, if greater than 50% is missing. Can you see? So this one is not telling us if you have more than 50% of your row missing, you drop that colon. You drop the row rather. If you know that in that colon that you have more than 50% is missing, because by the time more than 50% is missing, you decide to say maybe you want to do average, which is mean. Your average that you'll be getting will not be accurate, will not truly depict the data. But imagine you have those 1 or 2, 3, 4, 5, or like 10 or 20% colon missing. You can decide to give it the average or the mean like that. So, but if you have more than 50% colon missing, just drop those rows. Those rows that have missing data, drop them and just work with the one you have, or you try and get more data again. So an example is maybe missing credit history in loan data set. Might not be just talking more on this example, focus more on these 3. So also when you have cases where you have duplicate, how do you handle duplicate? That's what does that mean? You have repeated records. You have maybe a day and this particular information. You have John, you have this particular information. You have maybe James, you have that. Then you now have a day again. You can see he's applying it 2 times. But although you must be careful, is it maybe when they have first name and last name, the first name and last name is the same. You check that place, the first name and last name is the same. You check the other columns, you are having the same values in every column for that row. Then you know this is a repeated record. So what do you do in that case? How can you do it? You need to identify. You identify using df dot duplicate. Then you remove it. You identify with this duplicate with this one. Then you remove with this. So that is drop those duplicates. That is the method. In cases where you have outliers, handling outliers. So outlier means extremely values that skew analysis. This is skew analysis. You have values. Let's say you have 0 here, and you have maybe 100 here, and almost everybody's score is between this area or so. Then maybe you now have just one person having a score, just one person alone. That person is like, or that score is like an outlier. There are sometimes when you now to do mean or median, median, and almost everybody's score is within this place. When you do median of everybody's score here, it will be correct. But when you add this one person that is an outlier to this score, and you now say you want to get the median will be maybe somewhere else. It won't give you the true median or mean. Yeah, let me even use mean. So that is why sometimes we need to remove outliers, or do what, or you cap or remove extreme value. You can just say, oh, all the score must not pass this and must not exceed this, or that is you are capping or you are removing the extreme value. It's either you remove the extreme value, or you will say that any value that passes this value, just remove them. We don't want it. Example is a salary of 500 million in a data set where the average is 500,000. Can you see what I'm saying? A data set, you have a data set where the average salary everybody's collecting is 500,000, 500,000. So for you to be able to get down the salary of average of 500,000, you're having someone collecting 500 million. It might be an error because it might be actually 500,000, then there's somebody added 000 to it. So it might be an error. So, but when you have that, you know that any decision you want to make from there, it won't truly represent this person is not meant to be even categorized as people having this amount of what average of salary. So you already know this is an outlier. When you use this in your analysis, in your model also, it will affect the results. So in this case, you can just what you remove. So now you have normalization. So what does normalization means? When when you have features on what on different scale. Yeah, we talked about this also in a visualization class. Let's say you have some people score in the percentage 0 to 100%, while you have some people score 0 to 50. You can see that score of somebody in 0 to 50 and it scored 25/50, while somebody on the scale of 100 scored 25 also, 25/100 and 25/50. You are seeing 25 and 25, but they are not on the same scale. So when you just see 25 and 25, you'll be thinking they are getting the same thing. Meanwhile, they are not getting the same thing because their skills is different. Or you have maybe somebody's value age in years and that person's age in days, stuff like that. So you need to make sure they are all in the same skill, in the same unit or anything. So that is why we need normalization. So you can just try to scale, okay, those in 0 to 50, you scale all of them to 0 to 1. So somebody on the scale of 0 to 50 scoring 25, you know that person actually scores 0.5. Okay, so you scale it to 0 to 1. There's a formula for scaling this. All that is in our video for that. Just check those things out, you see it. So is that the person scoring 0.25/50 is actually having what 0.5, while the person scoring 25/100 now, I think it's actually having 0.25. Yeah, 0.25. So you can see 0.25 and 0.5. So you can see the person scoring 25/50 is higher than somebody scoring 25/100. So that is the essence of what normalization. Or maybe you want to compare attendance and hour study. You know, attendance is in percentage, but why the hour study is maybe between 0 to 20 hours. So you can see these are in different scale and you want to compare them together. So the best thing you just do is you convert this one, maybe you scale it between 0 and 1 or 0 and 5. Then that same skill, you apply that same skill to this. So that when they are both on the same skill, you can compare them to themselves. So that is what normalization is telling us. I also have encoding. Encoding is used when you have categorical test variable. So now let's say maybe the type of vehicle people are buying or the type of houses being built. You have maybe somebody with a flat and bungalow, somebody with duplex, somebody with a 3-story building, somebody with 15-story a skyscraper and all of that. You know, these are categories also. But now you can decide to encode them. That okay, those are our bungalow. You encode them, their value. You give them maybe that label of those with bungalow is 0. Those with duplex, you encode them maybe 2. Those with this, you give them a value 4. Those with this, you give them a number. So that is what you are encoding them. So you categorical test. So because when you are working on your model won't be actually now start reading, oh, this is bungalow, this and that person is bungalow. But when it's already encoded, it's easy. You just know that, oh, this colon is having 0 1 0 1 2. So you know that those with 1 is this. You will now be done to interpret. Those having 1 is this. Those having 2 is this type of building. Those having 0 is this type of building. It's just as if you are converting that test category into what? Into numbers. That is just to put it in a layman term. That is what encoding does. So we have label encoding for ordinal, and you have what? One hot encoding for nominal. This one is the most one that sometimes we use, one hot encoding. That is like the one I just explained just now for nominal. So now example, now you can see what I'm trying to say. Employment status, employed and unemployed. We have those. This. You can even have more than 2 categories: employed, unemployed, self-employed. So self-employed will be 2. You can give it any number you want based on how you encode your work. Unemployed is 0, self-employed is 2, employed is 1. So anytime it sees 1 in that column, it knows 1 means unemployed, Anytime you see zero, you know zero means unemployed. Anytime you see two, you know two means self-employed. That is just an example of what encoding does. So let me get a thumbs up. You are following? All right. So now for this, we are not done yet, but this is just like an assignment. You can try it. You can just search online for any data set, or if you can get this particular data set, a business funding data set. So you analyze and pre-process the data set by applying pre-processing techniques. So just to not make it easy, just get any raw data set online, then you clean it. You use a Jupyter notebook or a Google Colab. Yeah, Google Colab and Jupyter notebook, they are almost the same interface. So anyone you are using, then you analyze it. So you analyze the data set and you clean it. So you also have like a markdown that will show your observation from the data, what step you took and all that. So before, I think we only have exploratory data analysis. I don't see, let's see if you can quickly rush through this. Then we'll now come back to this. I want to do a data processing relating to this, but I'm not using this data set. So now for exploratory data analysis, is an approach to analyzing data sets. We want to summarize characteristics, we want to visualize our data. So you analyze and summarize your data using what? Visual method. So before you build any model, EDA will help you understand this is what my data looks like. When you first download it, this is what my data looks like. When you've processed your data, this is what your data looks like. It will let you see the patterns that exist, what problem is still remaining. So EDA helps us understand how our data is distributed. Is it well distributed? Is it biased? It helps us identify patterns, trends, and anomalies. Are there seasonal trend, unusual spikes? It also helps us to generate hypotheses for further analysis. So it looks like income. Oh, you just see it. Oh, it's like income is correlated with loan default. You might not be sure, but at least you can just, from what you can see, and it can dictate outliers and anomalies. By the time you use visual method, you might be able to see, oh, this one is an outlier, this one is a what is a bug, is an anomaly like that. So values that don't fit the expected range. So that's just like explaining further. And EDF guides us to be able to select the right feature. When we talk about feature, let's say you have a data set, you have age, number of family member, and type of ticket. I'm trying to use like a common Titanic data set. That is like example of things you find there. What parchment is the person in the shape and all that. Those things are features. Or in the terms of the students that want to know if they will pass or fail their final exam, the hour study, the their attendance percentage, and all that. Those are what future. So by the time you are selecting, sometimes you have a data set, it's not all your future you use in your model. You will need to select the right features. You need to drop some. These are the things we talked in the last section, in section 2. So the EDA will help us to do that easily. It will help us do that, to select the right feature for engineering and even for modeling. So what are the common Python tools that you use for EDA? The common ones, you have the pandas. Pandas, you'll be using it even while you are processing your data. You use it to load your data, to clean, to manipulate your data. Like you can describe, then get an info. You have DF value count. NumPy is another one for performing numerical computations on array operations. We have matplotlib. These ones are for plotting graphs like line chart, bar chart, histogram, scatter plot. Seaborn too, also related to matplotlib. This is for statistical visualization. So Seaborn can also do some of this and can also do more than some of the basic charts matplotlib can do. So we'll come back to this part. Let's dive into maybe a small practical in data processing. So I'm coming. Let's try and get a key. This like one of the code we did for data visualization. I'll create another code and download the data set from Kaggle. When you go there, you can just create an account. When you come to Data Hub, you can see data set, models, code. So, especially if you're into data analysis or data science, Kaggle is one of the best sites you go to, especially to get data set. To even get models that has been worked on, you check how the person actually work on a particular model, how they work on the data set and all that. So I just want to get a raw data. So what I did actually was to search for raw data set. That is what I did. I came to data of data set and search for raw data set. So let me go back. You see. So can you see this is what I actually searched for? So I just had to scroll through which one can I select, because I even get some data set that is just be images that might be inside. So I decided to go for this one of HR data set. So you can download, you can even check some codes they can use to clean it. So this data set now contains clean and raw data sets. The data part that has been cleaned, the one that has not been cleaned. So this is a simulation of human resource data. So it's bridge the gap between tutorial data and production data. So this is just for training, also learning. So this data set contains 2 million rows. Can you see that is a large data set? Very large. Even though if I want to use them, I have to drop some rows. We just need a small row, or maybe I should get a data set that is not large up to this. Let me check the size first. So this will also give you some more details about the data set you want to download. Can you see the size? So I think I'll just get a smaller data set, because by the time I start downloading this and start loading it into my code and all that, because that 2 million rows, but it's actually a heavy data you can work on. So now from here, you can explore your data. By the time you scroll down, you can see, you can check information about the data. You can see you have 31 columns. You have 3 files. Okay, the CSV one. You have 2 CSV. So you have the columns, you have the employee ID. This is actually good, but the size is just much. That is just it. It just need a small part of it. You have the salary, you have the years at company, job level, departments, you have different business units. Let me see if I can get a data relating to this that I can use that is small. Let me use HR raw CSV. Let me see if I can get this alone. I don't want to download everything. So you can just explore. If you are following me, let me get a thumbs up to know if you are following me. So this one of HR raw is also just 256 MB. It's an heavy data set actually. Let's see. Let me open another tab. Let me see if I can get another data set. I don't want something that will take time. Some of these data sets might actually even contain images and all. Because you can need data set for different type of thing. HR raw data sets. Let me just search that. Just 55 data sets. Okay, let me you see this. I think I might have to go with this. Yeah. Okay. This one contains employee information from a fictional company, department, employment status, recruitment sources. Okay. Let's go through this. This one is not much. This one is even an Excel file, not a CSV. It has 311 rows. Okay, this one we'll use this. This one is not much. It's an Excel file also self. We can still use them. Okay, it has employees, position, 8 columns. Let's just download it. I will start exploring later. So it's downloading. Sorry, let me create a new. You actually still come back maybe to check some things. That is for. Let me create a new notebook in Drive. So that one is loading. Let me open this also. Okay. Let me name it AI/ML section 3. So where is my, I'll try and import the files here. Okay. Let me upload. This is my data set. I don't know if that's uploaded. Let me check. That is not uploading. Sorry. Just trying to upload it to the section. So why that one is still trying to upload. I don't know why it has not uploaded. We import pandas. I know we need this as PD. I believe by now we should be familiar with programming. Import pandas, then what else are we going to need? Let me just, but I don't know why my code is not working in my data here. It's not loading here. Okay, I think it can now upload now. I'm right. Sorry. Sorry, it's my data that I don't know why it's delaying me. Or let me try and open Anaconda. Then I will try and load the data from my system. And I don't know why it's not uploading my file here. Because I don't know what is wrong with my section. Let me try and even reload the section. Section is not saved yet. So So when this one is trying to load, I'll try and reload the site. I just want to load that data and just do some simple processing that will see what we are trying to say. We'll import the data, we'll load the data, then we'll check it out to see if there's any missing column. Then we'll try and do maybe handling missing drop duplicates and all that. So that one is loading. Let me open some notebook. Okay, let's see if it will load now. Or is it because it's an Excel file? I don't think it's because it's this. Okay, now it's now working. So it has load the file there. So let me add to copy to path. Okay. Import pandas. Do I need any other library? So now it has imported the file dp.pd.read Excel. Okay. Right. They decided to just use them now so that it will make my work very fast. So normally what you do is after I've defined DEF is the data frame, PD, we are importing these pandas. It's like a library. Then we'll read Excel. Normally the most ones we usually do is read CSV. I don't know if you have a line here. Can you see something like this panda? Okay, we didn't use it here. We'll read it CSV. But now because this one is an Excel file, XLS, SLSS, this is an Excel file. That's why we are reading what? Excel. So this is a part in the main content here, HR, that will do what we display. So let's run this line. It will display the first 5 columns. You can see. You can see now. So you have employee ID, employee name. You have the position ID. So from what you can say, okay, maybe the first name and last name, first name, comma, or no, this should be last name. Anyhow, we don't know, or employee name. You can see their position ID, the manager ID, the ID of their manager, the salary they are collecting, the recruitment source, those how they were recruited, the date of hire, the date they recruited them, date of termination, those are they've terminated. So let's try and see if there's any other information here. So let's add a new. We'll check df.info. So especially these pandas, you should be familiar with some of those things that you can do with it. So let's check. So now this is telling us we don't have any missing with 104, no. So now how many columns do we have normally? 311 from 0 to 310. So from 311 to this one, so we don't have any missing column. Normally, I need the data that will give us missing column, then we'll fix it. So that's what we need. But now we don't have any missing column except this one, date of termination. And the reason why we're having date of termination we are not having for some. Normally, some are still working with them, some might no longer be working. So the best is normally this part will have be dropped. But let's check first. So another thing. Let me create another one. If this one does not work, I'll try and get another data set. df dot duplicated to check for duplicates. So do I have any duplicate? False, false, false. The role is actually much. So to actually check everything, let me create something the other time. I'm trying to see if duplicate, just give me the number of duplicates we have. When we have the number, maybe then I'll locate the position. So it's as if this data set has been cleaned. So let me see if I can get another data set that has not been, the best one will have been that one we didn't download. I just need a data set I can perform some things on. So that's one of the things in Cargo. You might have a clean data set like that. Or yeah, let me just come here. We just example of what I was trying to say. I think we have a data set somewhere here. Yeah, yeah. Let me use this. Let's use this. Control C. So now let's work with this one just because of time. So on your own, you can get a data set, get it, explore it. You can, just like the way we've done it here, check for some details to know if it's have duplicate, missing data, and all that. Then before you apply. So this one now, I'm trying to create my own data set. I gave employee ID, engineering, this department, marketing, this salary, this is years of experience, this is their performance. So this is the data. I'll now create it, PD expanders or data frame, then create this data and store it in this data frame df, just like you are creating a variable. So let's see. There's an error. Yeah. I didn't import something or what? MP, sorry. I didn't import MP numpy. That is the reason. I didn't have import numpy in my code. That you must be able to know. I don't need all this. So now let's go back to so we already have this created. Then let's now check for some information df.info. So maybe in the next section, that is the fourth section, we'll be getting more into creating models. So the reason why we are giving this because most times if you are getting your data from Cargo, some of the works might have been done from you. But sometimes if you still go, you still need to check your data to drop some things and all. And I think I gave a data set in one of the assignments I gave. So I don't know if that data is cleaned. If it's not, maybe you can even try and just see some things there. Sorry, Control Z. So let me just run this. So can you see now? 8. No, this one is having 7. We're having 8 entries. So that means salary is having a what? A missing colon. Is having a missing row rather. Salary. So what are we now going to do with that salary? We fill it with what? Since it's salary, we fill it with the mean. We fill the salary. Any problem, Alex? You're saying something, but I can see your reaction.
Yes, because the salary is not showing any, it's showing none. It's not showing there is a missing value. That's how I'm trying to.
It's a missing value. Let's view it out. I didn't put df.ed. You see now. How many
Okay,
entries do you have?
what I'm trying to say is, sorry, is that the rest, what is the distinguishing factor? Like the parameters, because the others are saying none, no. So I'm just trying to ask,
Okay.
how do
So
you
now,
know that?
okay, that no means that this we didn't have any empty. field, any missing field or any empty field here. So now, and you check from your range here, you'll be able to get numbers of rows. This like your rows and the columns. So you have 8 entries, 8 rows. So by the time you check your rows, you can see the number of counts now. 8 non-empty rows and like that. So you have 8 non-empty rows, you have 8 here, and you have 7 here. That means one row is missing. It's not having values in salary. So let's run this df.head. You see it. So can you see this is it? Because this data set is not much, I can actually check. So can you see this row? You can see that salary is missing here. So that is exactly how I was able to know. Sometimes you might be having maybe 311, like the other one that we have 311. You can see something here now. I'll also tell you from the data set. You can see saying you have 104. No. That is out of 311. It's only 104 that is having values. The rest, 311 minus 104, will give you the number of missing column here.
Thank you.
So you can see it from the DF here. Even from here, I already know. When I was in NAT, maybe not yet terminated or anything. So that's how you know you have missing column. So that is why I said salary is having what? Yes, yeah, salary is having a missing column. So that's why we are going to fill it with the mean. Let me see if you generate the code with DF. So now we fill it with the mean. So salary now. F. Fill the missing. Fill the missing salary column. It's mean. Is this salary column or row now? This stuff is just confusing. But I believe I get the point. DF dot easy is no. The mean salary now. Okay, the mean salary, DF salary dot mean. Then you have DF your salary, data frame of your salary, few non-available with the mean of salary. So let's check again. So you can see that the 5th row now has been filled with mean. The rest is having 000 here. But let's assume we ask it to round this up. It can round it up, the values here, maybe to the nearest whole number. We can write it, the code for it to round it up. So it's first created a mean salary. If I find the mean and put it into this variable, then we now put that to fill any missing rows with it. So that is just an example. We have some that may have categories and the rest. Let me see if I can get that. If I can get that part of Titanic data set also. Yeah, Titanic. Okay, let me open the file here. So, okay, let's check here. So now we fill the missing salary with let me delete this part. The missing row of the salary with the mean. This is the mean. There's my allow. So I'm trying to visit where the data set is. So this is an example of the data set. Yeah, this example of what I was saying the other time. Passenger ID survived. This survived now. We have 0 is equals to dead, 1 is alive. Like this has been encoded. Normally they can just decide to put survived, yes, no. So if you're having 0 dead, that is the person did not survive. 1 means what? Alive. This has been encoded. Even most all the data here, this part 2 has been encoded. First class, second class, they just give it a value. Yeah. So you have the name of passenger, then you have some other information at this side. So we have around 12 columns here. So you have the gender, you have the age, male, female. So you have all this one. Let's try and download the data set and see if you have any missing column. That's downloaded. Let's load it into our section. Tested, open. So let me import it here into my, create another thing. So pd df1. Let me name it df1 now. I'm not dropping anything. So df1. And another way now, this part of the salary now, we said something that if missing value is greater than 50% of our data set, we will drop it. If you want to drop it, it's suggesting something here now. So I can just drop that row here now. Let me come back from here. Let me run. But it's because if unless I want to reload it again, it has saved. I will have to start it from a particular part there, and I'll just drop this part. It will drop it, and I'll go on with the rest of my data. So sometimes, if you don't want to bother, if it's not much, just like 1, and you have enough data set, I can decide to drop it if I want. So, but since it's just 1, you can just fill it with the mean. Unless you have too much of missing field, then you drop. So pd dot read CSV. Then I copy the part of this data. Copy the part, copy part, paste. Then I will load this. Then df.add. df.add. I want it to even show the first 10. Something is missing. Read CSV. Something wrong. Invalid syntax here. Is there an error here? I've seen my error. Yeah. Pardon me. So you add your marker. So now it has loaded that data set now. You have this with this for engineering. It's loading the data. Oh, it's df I wrote here instead of df1. You can see how that's why I decided to name this, because whatever you use in the up, if I should write df again, it can rewrite what is up, but I want you to load them separately. That's why to add df1. You can give it any name you want. But this is why we usually use df just to represent data frame. So you can see the data set, it has loaded. So this is what we have. This is what we have. Can you see some not available in some places here? So I think we can use this. Let's now check. Let's check for info, df.info. Am I pressing enter? Sorry. So now, just pardon me, the way I'm used to writing df, and I have forgotten I've changed the name. That's why I keep writing df. So now you can see you have 4118 entries. Out of the 4118 entries, cabin is having 91. So the rest are missing. So what is half of 418? If you have a calculator here, just let's be doing some arithmetics. Half of 418 is, that is 209. So for cabin, you have more than half of your column missing. So we drop that column. We don't even want that, but we have too much missing fields there. So for this one, age 332. So we can still work with age, more than half. We have more than half. It's just few that is missing. So we work with age. This one is just only one column. This one. So the missing column part is age. Here, we drop cabin. So let's first start it step by step. Let's first drop cabin. df1 equals to, so suggesting something for me the other time. PD, let me use PD drop any. Right. I want to drop a colon. That's what I'm trying to do. The df salary drop. To df we are dropping cabin. And did I create another one up there? It's not dropping, sorry. There's an error. Let me just fix it a lot of time. Okay, I use df. God, I think I'm just, I don't know, sorry. But let me try and get that line. I think it's df I use instead of df1. Just be pardoning some errors I'm having here. This df1 and df is confused. I'm used to using df most of the time or using another thing entirely, but I usually forgot the df part there. So let's now load that df1 again. df1.add. Because I was actually wondering why it was giving me error again. So let me even put this one. Cut. Move this one down. Wait, just why is it loading only? An error has occurred here. An error has occurred. df1 drop. It didn't even check if there is duplicate, but let me try and load all this again. Let me load it again. Load this again. This part. Drop cabin colon. Drop cabin colon. So we drop the cabin colon. After we drop it, then we'll come back to age and fill it with min. We do the same thing for the rest. So let me move this one up, move it here. So drop, you can see df1, okay, drop, then the column name that I want to drop. So the cabin column has been dropped here. You can check, you don't no longer have cabin again. So now let's now fill this age with the mean. You also fill the what? The fair with the mean. So let me just because of time. Come back here. Where's this? Control C. So now using df1 here, mean age. We're doing for both together, mean age. Let me see how the age was written because you must is capital A. If not, you'll be getting error. Age with the mean, then you fill it with the mean age here. Age. This one now I'm done defining it, so I can give it anything I want. So that is why I didn't have to make the beginning capital there. But this one is the column that is available in our data set. So this one will also be age also. Then I'll do the same thing for fierce. Enter. I still need to go and check that also to check the proper, okay, fair, okay. Yeah, and also one thing we didn't check before we started changing, converting with mean. You can check age. So we use the mean. These are numbers. When we check fares too, it's just like amount they paid for their tickets. Because we need to be sure what type of data is in that column that we want to fill. Because if it's like category now, you can't use mean for category. You use mode for category. So that is just one thing to note. So we didn't check that. But even from the name, we already know what type of data they will have. So that's why we just started working on it direct like that. But on the norms, you need to check. And something is still missing here. Something is missing here that I will write it down and start getting error df1 because that is what I use for my data frame to name it. It has been causing error since. Then this is here. Here. So then df1 display. These are the things that has been causing error. So let's see. Can you see now? So you've done that. So now let's now check for you have any is dropping and deleting the same thing. So let's just say it's the same thing. The reason why is because once you drop it, unless you use different name for it, let's say you imported your data using df, for example. Then when you started performing, the best thing is once you import your data, df, or give it any name. Once you want to start performing all these things we are doing, dropping, deleting, you name your data frame, give it another name, maybe cleaned df or process df. Hope you are getting me. So that is like the best practice. Once you do that, when you drop, it's as if you deleted it from that data frame. But in case you need that colon again, or you want to do some things, you can just go on to the other one you loaded, that df, then just go on and perform some things you want to perform. Maybe you now create another one, cleaned df2, then you now get your data from that in df, the data set or the data frame you created. So in that way, you can work on it anytime because dropping here is like deleting. You are deleting that row. So when you are working, you create it with another. When you start working on this cleaning and all that, for data frame, create another name with it because there are some times you might have deleted it and be like, whoa, I need this thing back. No, like what I did this other time, this place. You see that I had to go and reload my data frame again. So that is assuming I've created it with another name, I'm going to have to load my data frame again, because if you're having a heavy data set, it will take your time again. So what I just had to do is I would have just go there and reload it, create another name instead of df1, df2, then load it from that first df. That is the best practice. But thank you for bringing it. So dropping is like you are deleting. But if you created it with maybe like a different name, you can go back to that first data frame you create and get it from there. So let's delete this part. So let's now check if our missing values have been fixed. Let's check. So df1.info. So you can see that we've removed that cabin. The reason why we have to remove the cabin is we have greater than 50% of the field missing. That's why we have to drop that. Then now for the missing row, you can see that none of it is missing now. We filled everything with min. Yeah, another way to display, you can see this now, is displaying the top and the ending, the top 5 and the last 5. What you use is what display. When you use display, that df, it will display the top, the head, and the tail, instead of just using display head alone and display tail. It will display the end, the head, and the tail rather. So when you use display, so let's check. I want to check the age part. You can see the reason why. That's why it's even having more 0, 47.0, 62, 30.27259, and all that. So let's now check if you have duplicates. df1. How did I check duplicate the other time? df duplicate. See, I check duplicate. Yeah, df1 dot duplicated. Then I had to put some to check something there. Yeah. So now let's check if you have duplicates. df1 dot duplicated. So this is even part of the slide I was using for us. It was telling us a place to check for duplicates. You can see there. This is when you want to drop duplicates. This is to check. So this, you use this to drop the duplicates. So you can see it's bringing false. This is like each column, but I might not be able to see some parts in the middle. So let me add this for it to sum it. Assuming we have some part that is having true in the middle, get the sum for them. For me, let me see. So if I'm having more, is a number here that is not 0, that means we have duplicate, and that is not giving me the number of duplicates we have in that data set. And in that case, I can drop it. Hope you are getting me now.
Yes, sir.
So let me create a scenario with our first data set that we created here, this one. Let me create a scenario with this. I will name this. God, okay. Let's try and see how it will go. I'll create a duplicate here and we'll drop and we'll see. Then I'm trying to recreate this first row twice. 101, comma. The person is in engineering. Control C, Control V. I'm creating it twice. Then the salary of the person is 85. Sorry, let me quickly plug my PC. So So we have 85,000. So we have years of experience, 5 also. So let me load this. So load this again. You can see the entries has increased to 9. So it's not giving me any missing. Okay, salary is still giving missing now because I had to reload the data, but I'm not going about the missing part again now. So now let me load. It's 9 that I have, but let me put 9 save here. 9. So you can see that this first column is coming out twice. So now let's check for duplicate. df duplicated. Let's first check that first one, then I will now get this one. So you can see that this first time is applying, is bringing false. The second time that same information is coming, is giving me what? True. That means this is a duplicated row. Can you see that? So now let me df dot duplicated dot sum duplicated dot sum. Sorry, there's an error here. So you can see that it's bringing 1. That means we have 1 duplicated row in this data set. So the next thing I will now do is df dot drop duplicate. So then once it's dropped, display df. Display df. So I ask it to drop that duplicate. It has not dropped the duplicate yet. Something is happening. Why is it not dropping it? Okay. df should be equal that drop duplicate. It should not be what df is now. Return duplicate rows has been removed. I think I need to create that stuff again from the beginning. Something, it has removed the duplicate, but because I wanted to display it and I didn't store it into the right place, I was unable to fill it. Let me create the duplicate again. You have 9 rows showing this. So you have duplicates. Yes. Then you have this. If you bring 1, I'm trying to create it again. That is example when you drop it has deleted that. That one has gone. So now I see still bringing. There is no more duplicate again. So that is why it's bringing error now. But let's display our df. Let's see. df.add. Let's see what we have. We really know what is going on. Something has happened to df. df that we are using just now. It's bringing df automatically is bringing error here. Load again. Load again. Load. So we have 1. So let me try and drop duplicate row. Let's fix that line for us. So we've done filling missing data. So we've done dropping duplicates. What else do we have here? Handling outliers and all that. This is when we are able to do visualization. You'll be able to see that. Or there are ways you can also detect that. And we also have normalization, putting them on a scale. I think we did that in one of the classes where we had to put our data in scales, like from, I think we did that when we are working on libraries. So, and the last part is encoding. Maybe that encoding when we get to section 4 or so, when we start working with model, we'll be performing encoding when we have categories, especially when we'll be working with classification. When you are doing the classification part, you will really work with encoding. So let me accept. So df.drop duplicate. Why is it not giving error? Don't give error now. So it has now worked. So I think I had to reload my cell again because this was actually what was written before. I don't know why it was bringing that error. So you can see that it has dropped that duplicate row now. I had to drop it and store it into my DF. Then I can display it. Or if I want to make it drop the duplicate, what should I have done? Should I have dropped the duplicate in DF2? I'm using DF1. So in that way, I'll display that DF2 and it will show it. Because this one now, if I need that part again, I'll have to start going and loading my data again. So that is one of the disadvantage of it rather. Because sometimes you might decide, oh, I don't want to drop again, especially if it's like a missing field. You might decide not to drop again and want to find something to put there. Or you can decide that, oh, you've gotten the correct thing that wants to be there, assuming you are the one that actually extracted the data yourself, if it's not that you are getting the data from somewhere. So that is us for that. Let me delete this. So that has been sorted out. So I think I was trying to explain normalization. Let me see if we have it in, we've done it in one of our classes where we did normalization. Yeah, this is it here. If you can recall. So where we have this score, 10, 25, 4, 87, 56, 3, 72, 19. So we want to normalize it. We don't want it to be more than, we want to normalize it between 0 and 1. We want to normalize this. So let me just copy this. Let me copy it. And you see it. So let's normalize. So we can also try it for our age that I want to normalize the age. But let's first try this one that I want to do. Then we'll now try something with age. Then we'll create a new DF, DF2. Because if we don't create any DF, it's in case we want to use our age back, we have to start working on it again. So we'll write a code here to normalize. I think I have the solution of this also. Let me, because of time, I don't want to start searching through. Normalize. Sorry, what's happening? Normalize raw. So what we will now do now is we want to normalize. We have age now because we have age. So we don't want maybe, okay, let's use maybe the amount they paid, fee or age, any one of it. We'll use one and we'll normalize it between 0 and 1. So let's use age. We'll normalize our age between 0 and 1. Then we'll see. Accept. So can you see it has normalized this one now? This one that we have here. It normalizes between what? 0 and what? And 1. So let's create another empty cell here. So normalize the age colon in normalize the age colon in df1. Normalize the age colon in df1 between 0 and 1. and store in normalized age, then add normalized age to existing, add normalized age colon in df2, add normalized age colon with existing colons. Store in df2. So let's see, because of time, if I start having to do all this one by one, so because some of the syntax you might not know them, or you need to just check, okay, the syntax for this, get them. So now we have our age in df1 now. Let's accept. I don't want to run them in case. So now minimum age. So this is to get the minimum age in that df1, because our colon is what our data frame is df1. So it will get the minimum age, to get the maximum age, and there is a formula for this normalize based on what we have here. X minus minimum greater than, divided by rather max minus minimum. So that is the formula. Then this is what we have to put here. So the df1 normalized age will now be this. Then we will now copy, because we have this in df1, we will now copy it into df2, which is what I asked you to do and display. The reason why I did this, I might want to need my df1 later on. That is the reason why I had to do that. So it's df2, it's go, but it's copying it. Meanwhile, anyhow, let's see. You can see now we have age here 34.5. Then that normalized age, I think it will add it at the end. You can see the normalized age here at the end, 0.425. So now we can know that, oh, the oldest person will be having what? 1. While the youngest person will be having 0 or close to 0. Hope you are getting me now. So when you normalize it, we are able to know this, like the other person, this is makes it easy for us based on the scale we are giving it. So this is 0.6, this is 0.8, this is 0.2, like that. So we know that even with the age normally we'll know. But in cases where we have your data in different, maybe now even a month, the amount this person might be paying might be in dollar, this one might be in euros, like that. We need to convert it. So in that case, we are not normalizing between them. We can just say, okay, let's normalize this based on their conversion. So we'll do some calculations that will be more than this simple one. Because firstly, we need to convert their currency. It's either we convert the currency of one person into another one and have them in the same currency, or we convert the amount, that currency, maybe into like a sort of like percentage or a range. We will have the maximum amount in that currency is that they can pay for a ticket, the minimum they can pay, and like that. So that is just for normalization. So this is just what we'll be doing today. So we'll just try and dive deep into the data process. That's what we did. And there was an assignment. So what I did, this is an assignment for the level 2. So I just had to use that data set to do some things. So, but there are some required tasks that you do. Maybe you can just use this. I need to do that task, this task. Even some of the codes you need are already in the task. You might just need to do some little editing or some little modifications based on what you want. Yeah, so, and that is for that. This is what we'll be stopping tonight. So next section, we'll be going into section 4, where for exploratory data analysis, there is a video on that. Yes, I've made the link public for that. So we'll be going into ML workflow and Python for AML. What are the type of library we'll be using for that? So the steps and all that. So we'll just talk on that. Then even from next section, we'll start working with some libraries. Then the following section after next one, we'll be getting into some little projects, projects One of it we plan on doing is a loan default model, and we'll try and see one or two models too. We'll just work on them. And just then after we have another section to talk, to give a deep intro into deep learning, where we have CNN, where we use layers. That one also has advantage, especially when you are working with data that has images. It's not only for data that has images, but data that have some complex or hidden patterns. But when you are working with simple data sets, just work with the normal machine learning algorithms you have. Don't stress yourself too much on deep learning. So, all right, so we're calling it a day here. I hope we are able to get one or two things from this section.
Yes, sir.
Okay, all right. So we'll see you next week in another section. Thank you very much for joining.
Thank you, sir.